Hello everyone, in this video we are going to learn how we can make the communication between two different network. But before going to that different network, we will see how we can make the communication between same network. So this is a simple lab. I will take two machine. Imagine this is a two computer and now you are connecting this computer. So you will take this cable, this is automatic cable, you will connect this way, and now whenever you are testing the device, you should have the IP. Without IP, it will not work. Without IP, it will not work. So you should have the IP address. If you keep your mouse here, you can see here for the fast Ethernet 0, you don't have any IP address. Even the IPv4 and IPv6, you don't have anything. So what we will do, we need to assign the IP. So you need to remember, whenever you are connecting the device, the device should have the same subnet IP. Example, I am connecting this device. You need to remember directly connected. I am connected here directly. Or if you see, maybe I have one PC here. Okay. I have one switch here. And again, I have another PC here. So this PC also directly connected. If I connect one router here, this router is also directly connected. So this interface, example, you have this fast Ethernet, here is so fast Ethernet, and here also fast Ethernet 0/0. This all interface should have the IP from the same subnet. If they are in the different subnet, then they cannot communicate. So you need to remember, whenever we are connecting any device, the directly connected IP should be in the same subnet. If they are in different subnet, it will not work. Example, here I am assigning 1.1.1/8. Here I am assigning maybe like 1.1.1.2/8. And here I am assigning maybe 192.168.1.1/24. Then this machine cannot communicate because this interface IP should be same as this machine subnet. If you are putting here the class A subnet, here is a class A subnet, and they are connecting this way, it will not work. It will not work. If you want to make the communication between all this device, then here also you should have the some IP. Maybe you can have here like this 1.2.2.2/8. This first network portion should be same, which is connected directly. Okay, so you need to remember that one. So now we will do one basic lab here. After that we will do a complex. So what we will do here, we need to assign the IP. We have the different classes. I hope you already studied that one, class A, class B, class C, class D. These three classes we are using in our organization to configure to any device. Maybe you have the server, router, or you have the printer, scanner, IP phone. In DHCP also we are using only these three, 1, 2, 3. This one, and we have E also, class E, class D we are not using. So you need to focus now currently in the class A, class B, class C. Class A is having the /8, class B is having the /16, class C is having the /24. Okay, you need to remember this one. Now let's use the class A IP. So how we can assign the IP? If you want to assign the IP, click this machine, go in the dashboard, click the IP config, put the IP here. So I will write here 1.1.1.1. Okay. So this way we will assign the IP, and the subnet mask will be 255.0.0.0. By default, you will get this subnet mask because this is a class A. Okay. So this is the IP I assign to the machine. I will copy, and in this machine label I will put here. So by seeing this label, you know this machine is having this IP. And here I will put some label here also. Example, I will write here 1.2.2.2.2, and we will assign this IP to this machine. So I will go to this machine desktop and I will go to IP config. I will assign, and this is also class A. And now you can assume this will work or not. These two machines can communicate or not. It will work. Why it will work? Because if you see, this is a class A. This IP is from class A. Class A is having /8. That is one network portion. Remaining will be the host portion. So you need to focus network portion of the both device IP should be same, then only they can communicate. If network portion is not same, then they will not communicate. So if you see, this is a network portion, this is a host. So host no need to see, only network you need to see. So network is here is 1, here is 1, so it will work. How I am saying that one? If you see the subnet mask, I am writing here 255, remaining I am saying 0.0.0. So I am saying only check the first part here. If that is work, then it will work. Okay, I am saying only check the first path. If both device is having the network portion is same, then no issue, it will work, because we are indicating here 255.0.0.0 means only check this portion. If both portion are same, they are in the same network, they are in the same subnet, then it will start, then it will work. Okay, so what I will do, we will test now. So I will go to this machine, I will go to CMD of this machine, then we are going to send the ping packet. First of all, let me check the IP, what IP we have to this machine. I will write IP config. Okay, IP config, and if you see, this machine is having this IP and this subnet mask. We don't have the default gateway. So now what I will do, I will write here ping and write the IP of the other machine. So I will write here IP of the other machine. If you see, replies coming means both machine is communicating to each other. Both machine is communicating to each other. And if you want to cross check here, you can go here and you can do the ping command from here also. So I will write here ping 1.1.1.1 and you will have the reply back. So it is working perfectly. If you want to check the packets, you can go in the simulation mode. Okay, after that you can take one packet from here, drop here, from here to here you want to test. So when you go in the simulation mode, you will have this. After that you can compare, you can check the packets will appear here. So I will play this one. So this packet is coming here. If you see here, packet is coming here from last device, that is 1.1.1 to 1.2.2. and if you want to check what is present inside the packet, you can see this is a ICMP packet coming from 1.1.1. Double click this packet, it will open. If you see, this is a OSI model of the packet. If you see, this is the OSI model here at the device, it is present here. This is a source IP. Source IP is a PC1 and destination IP is a PC2. And if you see here in the layer 1, you have the port fast Ethernet 0x0. Layer 1 means physical interface. And then you have the layer 2. In layer 2, you will have the MAC address. So if you see, Ethernet header is having the MAC address. And then you have the layer 3. In the layer 3, you have the IP address. So in the layer 2, you have the source MAC address and destination MAC address. In the layer 3, you have the source IP and the destination IP. Okay, if you want to check inbound PDU detail, go inbound PDU and you will see here the detail. What you have the Ethernet frame. In that Ethernet frame, you have the source MAC address. Okay, and you have the IP packet. In the IP packet, it is showing I am using the IPv4, and you have the other detail about checksum value. You have the TTL value here, and you have the source IP, destination IP. Then you have the ICMP packet. In that one, they are sending the checksum value and the sequence number we are sending. And then if you see outdoor, that is outbound PDU, that will have this from here. Inbound means coming from here. So now outbound, if you see, same thing, you will have source of destination MAC address, source MAC address, IP packet. If you see, this is a source IP. This packet is going from back from here to here. So this guy will become as a source. This guy will become as a destination. So if you see, source IP is 1.2.2.2 and destination IP is 1.1.1. So inbound means coming from here, and now this one is going from here. Okay, so this way we can read the packets also. And in the EVNG GNS, you can capture the packet from the Wireshark also. Okay, so you can play this one. So if you press this button, it will go here. The ping come back and it is successful. And if you want to bring to the normal mode, click the real time. So it will become to the normal mode. And this is a logical topology. If you want to see the physical topology, you can click the physical and you will see the home city, then click here, then you see the office here, click here, and this is the device is showing. And this is our table, and in that one we can check also. We can go here, zoom in, zoom out, and we can verify that one. Okay, so let me check where we are. I think our device is outside, so we can go here and check inside. We can add the device also here. If you see, I add the rack. If you want to add more device, you can add also like this. We can keep from here. We can keep from here. Wherever you want to put the device, you can put it like this way. This is a server. Example, I want to install the server. We can install and we can connect from the cable also. We can use, maybe I want to connect from here to from here, where I want to connect from here to wherever you want to connect. We can connect also like this way. And if you click the logical view, you will get that where you keep the server. We keep the server here. Okay, this is the server. And if you bring this machine here, and then if you bring here in this area and again go to the logical view, you will have your machine here. So anyhow, this one you can play with this later, but main thing what you can see, this is a logical view, this is a physical view if you want to check. And if you want to access, just click here and access the command from here. So in this one we learn only how to make the communication between two devices within the same network. Okay, so in our next class we are going to learn how we can connect the different network. Thank you, bye.